Welcome. In this example, I just want to give some of the in this lecture, I want to give some of the standard examples of continuous functions so that continuous functions, there's a lot of extra stuff you can do with them. We have a lot of tools to work with. There's going to be a lot of theorems, things like this, that are only going to hold for continuous functions. So it's good to know what those functions are, and you know, oh wait, I'm dealing with a continuous function. I can do all these things. It's amazing. Or, oh, I don't know if this function is actually continuous. So, and we'll cover the circumstances in the other lecture. But in this one, I want to go through some of the circumstances where your function is continuous. So you can do all the things you want to do almost. Okay, so let's get started. So you have polynomials. Such as, so we have, I'm going to draw 3 here. Okay, so I'm going to do them in different colors so that you can kind of, so that they don't blend into each other. So we have functions, we have linear functions. We have functions like this. We have f of x equals, that means minus x plus 2. Or you can have quadratic functions, right? So these are polynomials also. Okay, so this could be, maybe this is g of t equals, right? Nobody says that our axes have to be x and y, or that our inputs are t, or t, for example. So this is 2t squared minus pi. Okay, so we know from this one, my inputs here are x, and so I'm going to label this x. My inputs here are t, so I'm going to label my horizontal axis t. And then this one, I'm going to look at, I'm going to have my input be w. So I was trying to remember what I had there, or see what I had there. So I have, this should be the graph. So this is the graph of the function h of w is going to equal, and then I have e minus pi w cubed. Okay. And then, so here you can tell that this is the w-axis. So any of these, and we can, we know that we have higher order or higher degree polynomials and so on. So there's a lot of different polynomials in existence. And these are just some examples. So then we have trigonometric functions, where they're defined. So some of them, you have to restrict the domain for this to be true, but for these two functions, you're really great. So we have t of theta equals sine theta. Okay, so this is now the theta axis, and it's going to look like. Okay, and we also have, maybe we'll notate this. I like kind of mixing up my variables so that you can get used to understanding that variables aren't always x and y. So now our input, this is actually our y, because our y is actually our input. And then we're going to have, we have these special functions that we're going to deal with a certain amount. So we're going to have w of t equals e to the t. So these are e to the x, ln of r, were defined. So we have okay, so let's make this, this will be r. This one is going to be w of t equals e to the t. So this is w of t equals e to the t. And then we have make this one red. look something like this. So we have, maybe this is P of R equals ln of R. Notice that it's not defined for negative numbers, but that's okay. So its domain is just positive numbers, positive real numbers. And then we're going to have compositions, sums, and products of continuous functions. So for example, I could take, maybe I want my f of x to equal equals 3x squared cosine of x minus sine of x. Okay? So what's going on here? Continuous functions, we know that they're ones that basically you don't pick up your pencil. And you can see this in all of these graphs that I've drawn. You have all of your polynomials are always continuous. With trigonometric functions, these ones are good. You do have to watch out for, sometimes people will talk about other trigonometric functions. And for those ones, it's only on certain domains. So for others, it's only on certain domains. Right, they're only continuous on certain domains. So that's a little cautionary note when it's talking about trigonometric functions. E to the x, ln of x. Again, the domain is restricted for ln of x. You can only input positive real numbers, but as long as you're on the correct domain, then you're continuous. And then you can combine these in terms of taking composition, sums, and products, and you'll get continuous functions. So I could even take something mildly crazy like that and know that it will actually be a continuous function. Okay, so I hope that made some sense, and I will see you in the next lecture.